It's Miss Sayer here in the classroom. I hope y'all are ready for another video in the Science Quest series. This one is all about chemistry. The purpose of these videos is to give you a chance to learn a little bit more about the science that we covered in survey this year and to think about which kind of science makes you the most curious and what classes you might be interested in taking in the future. Hey folks, welcome to the lab. What we have here is an acid-base reaction, and it's one of my favorite examples of how beautiful chemistry can be. To set this up, I put a different kind of indicator into each of these 6 beakers here. Remember from earlier in the year that an indicator is a substance that's going to change colors in the presence of another kind of substance. So for example, we had BTB indicator, which was a CO2 or carbon dioxide indicator. That changed colors when you blew into a straw, getting your CO2 into that liquid. These indicators are base indicators. So when I poured sodium hydroxide, which is a basic substance, into these beakers, they changed colors. So the violet one will change violet in the presence of a base, the blue one will change into blue, and so on. In order to remove the colors, I added an acid, which was hydrochloric acid. Now, unfortunately, you're not going to be able to recreate this exactly at home, but I am going to show you a way that you can do an acid-base experiment in your own kitchen with materials that would be safe enough to even drink, although it's not going to taste very good, so I don't suggest it. All you need for this recipe is a blender, some water, some kind of strainer, and some purple cabbage. Step 1 is to put your purple cabbage leaves into your blender. Step 2 is to cover your cabbage leaves with water. Step 3, blend it up. Step 4 is to strain out your juice. So I'm just going to pour my cabbage juice through this strainer and catch some of it in the beaker here. Make sure you clean up any spills as you go because it can stain your clothes. That was the whole recipe. Easy, right? Now you have an acid-base indicator that you can use to determine whether different liquids in your household and kitchen are acids or bases. Let's check it out. This kind of indicator works best on liquids, so I grabbed a few different liquids that we can check to see how this indicator appears in the presence of different acids and bases. Right here I've got milk, lemon juice, and vinegar. Let's try it out on vinegar first. If you've ever done an experiment with baking soda and vinegar, you're probably familiar with the fact that vinegar is an acid. So this is going to show us how this indicator appears in the presence of an acid. In the presence of an acid, I can see that this indicator is going to change from purple to bright pink. Next, let's check out the lemon juice. This indicator also turned pink in the presence of lemon juice. That matches pretty much the same color as the vinegar, so I can tell that these are both acids. Next, let's check out this milk. Watch what happens now when I pour the indicator into the milk. Instead of turning pink, this one is lavender, a purple color, almost the same as the indicator, but not as dark. This might make you think that milk is a base, but it's actually a very weak acid. If you create a pH scale with cabbage juice indicator, purple is neutral, meaning not an acid or a base, like plain water. Bases will be indicated with blue, green, and yellow colors. If you keep your experiment in the kitchen, you're most likely to find weak acids and bases, and that's because that's what we can eat and drink without them hurting us. Strong acids and bases would harm you if you tried to ingest them. If you venture into other rooms of your house, like your bathroom and maybe your garage, you'll probably be able to find some stronger acids and bases to check out. But make sure you tell a parent what you're up to and be careful because some of these cleaners can actually hurt your skin, they're toxic, and they can definitely stain your clothes. This is isopropyl rubbing alcohol, which is something that you can use in a first aid kit. If you get a scrape or a cut on your skin, then this can prevent infection. Let's check it out. I can see that the rubbing alcohol stays this nice dark purple, so I'm actually starting to make a color spectrum here, going from pink to purple. Here I have Clorox bleach. If you're gonna test cleansers like this, be super careful because it's corrosive, which means that it can cause chemical burns, blindness, it's toxic, and it can even stain your clothes. Bleach has a really interesting reaction, so I'm gonna show it to you up close. Take a look. Bleach is interesting because it's such a strong base that it actually turns this beautiful dark blue-green color. Once you've tested out a few different substances in your home, you should be able to start to see a spectrum that shows the different colors that this indicator turns, whether it's in the presence of a strong or weak acid or base. Experiment with some different substances in your home and see if you can identify some acids or bases that you didn't know about before. Send me a picture or video and share your science with me.